Hello, everyone. My name is Scott Grisard from the University of South Florida. This is the review for Quiz 6B. As usual, we are in both Twitch and Blackboard Collaborate Ultra. Twitch because the video has higher quality there. If you want to ask questions, you may ask them in Twitch chat, or you may ask them in Blackboard Collaborate Ultra. Of course, if you ask them in Twitch, they're public. If you ask them in Blackboard Collaborate Ultra, they're private. Also, I will be doing the 1 to 5 surveys in Blackboard Collaborate Ultra. Are there any questions before we begin? Yes, so we'll be doing the problem set today. Someone had asked if are we doing the problem set. Yes, we're going to go over the quiz first, as we do normally. Okay. So good question. So that first question, let me see here. Everything is updated. There we go. And seems to be working, which is a pleasant surprise. All right. Now, this first question, I said this before last, and I already posted the 11 a.m., so you may have seen that already. But the chain rule is one of those things that's harder to state than it actually is to use. So the easiest way I've found to do it is to do the chain. This is actually a mathematical object. This communicates. Let x go to u, go to y. If y is differentiable at u and u is differentiable at x, then y is differentiable at x, and dy over dx equals dy over du times du over dx. It's not the most useful definition when you're trying to use it, but it's actually a fairly good, it's the most compact way to kind of write it, if you wanted to write all the details. Now, it's not my favorite way. My favorite way is this useful way. So let's do this useful way with everything together as well. So what I would write if I wanted to write this, and again, these are alternatives. Let me go ahead, and these are kind of the minimal alternatives, but let's go ahead and expand this one to show what's kind of everything that went into it. So let's let x go to u, go to y, and I'm going to put an f over here. Okay. And I'm going to say if f is differentiable at u, and the function here containing this, so I'll write a little g up there, and g is differentiable this is actually two conditions. And if g is differentiable at x, then and I like to do it like this, then you can either do f circ g. This is kind of the way that the book does it. Then f circ g is differentiable at x, and this is one of the reasons why I write the little g up there, because now I don't have to write the g of x bit. Okay, I can just write d over dx of f of u equals d over du f of u times d over dx of u. But note, if I don't say what g is, note, I need the drawing to say what g is. Another way to write this that's actually a fairly good way to do this. Another way is with the same preamble, but write the conclusion another way to write the second conclusion. With the exact same setup is to write and f circ g prime of x equals f prime of u times g prime of x. And that's actually a very good way to write it. But again, you have to have that exact same preamble you had before. So you actually have to say what these things are. I think this is the easiest way to do it, or this is the easiest way to do it. The easiest way to write it is just to forget about the f and g and just write it this way. I think the most useful way to write it is this way. But you can get away with this, and you can get away with this as well. Are there any questions about that? So do what works for you is what I'm saying. Stating the chain rule. One to 5. How do we feel about that? Okay. There are lots of ways to do it. I've kind of given you the kind of ways that I think are easiest. Some people like this form where it's f prime of g of x. I find that confusing as can be, but, people are different. Okay, let's talk about this one here. All right, so this next one, I'm going to take the derivative of sine of cosine. So what I'm going to do is I'm going to take the chain rule. And notice here that I have an x here, right here, and now I have a u here. That's kind of the point. So the chain rule says that I can separate that. The chain rule says that this is d over du of sine of u. I called this thing u, and I just made a sub. And then I have d over dx of u. And this kind of communicates, of course, the fact that I said chain there helps, but this shows that I used the chain rule. And notice I changed the variable by which I was differentiating. That's kind of the key about what the chain rule does. Okay, so then I evaluate this derivative. I do cosine of u, and I subbed in the u. Then when I do cosine of u, I get negative sine. Cosine of x. When I do the derivative with respect to x of cosine of x, I wind up with cosine of u times negative sine of x. And then I have to sub back in my u. So my u was cosine of x, so I sub back in my u. And the journey of x looks like this. So I started with x, and then x got cosigned, and then I got sine of cosine of x. So that was just kind of the journey of x. How do we feel about that 1 to 5? Let's see. What happened to my poll from before? There it is. Okay. There are 15 people here, and 7 decided to vote. Okay, so that's a good question. So someone's asked about the notation for sine and cosine. Okay, so the book is going to do... Why does that keep... Oh, because the mouse is over it. I see. Okay. I don't know if there's a way to move my mouse so that doesn't keep happening. Okay. So there isn't. So what's going to go on here? So the book wants to do sine x. I don't like this notation because it doesn't say what's going on. I don't think there's a way to stop this little doohickey that's kind of up there appearing. I don't know if there's a way to make that go away permanently. Oh, there it went. Okay. So sine of x here, this notation here, that's okay. The problem is what happens when I do sine, cosine x, right? It's not entirely clear what's going on. Whereas if I write sine of x with that thing there, right, I'm going to get this. The other thing that drives me nuts is sine squared of x. This notation is very... So this emphasizes the fact to me that you're doing a function, and it keeps things grouped nicely. Because what if you have sine x, or sine x, cosine x? It's not entirely clear what's going on there. Whereas if I write sine of x, cosine of x, it's kind of more clear that what I'm doing is multiplying them. Also, what happens when I do this? Sine, cosine x. Did I forget to write the x? Are they all together? You know, if I write the parentheses, write the parentheses. The other notation that I hate is, if you do this. So never, ever, ever in this class do this. This will get you into trouble. Because what's going on here? Well, what's actually going on here is that sine of x is being done first, and then it's being squared. So better notation for this right here, better notation is sine of x squared. Yes, it's a couple more pen strokes. And the reason why this notation will get you into trouble is that this does not equal 1 over sine of x. Okay? Okay, so please, that's why I hate this notation. Sine negative 1 of x actually means arcsine of x. It's a different function. It's the inverse function, not the reciprocal. Okay? So please don't do that, because you're going to confuse yourself. Does that answer your question regarding sine? Can you leave it off? Yes. Should you? Really, no. Please, no. You will make yourself so much happier if you actually spend a few more pen strokes and write the parentheses better. Because that notation can actually confuse, and I hate that. Okay. Back to this. Here, the journey of x for part B. I'm going to start with x, then I take the natural log of x, and then I have x here I have log of x to the 1/3. So the last thing that happens is this 1/3. So that's going to be the first thing I deal with. I'm going to let u be the stuff in the middle, the ln of x, and then I'm going to take the derivative. So I'm going to do d over du. I'm going to apply the chain rule. I'm going to get d over du, u to the 1/3 times the derivative of u. So when I evaluate this derivative, I get 1/3 u to the 1/3 minus 1 times the derivative of what's left. And that gives me 1/3 u to the negative 2/3. This was a fraction, so I just write them out. Sometimes I don't do it if it's 1/2, but just about everything else I do. times 1 over x. And then because this I created, so I'm done with the calculus, but because I created that u, I have to sub them back in, and I get 1/3 natural log of x to the negative 2/3 times 1 over x. Now, if you wanted to simplify, there it is. That's what it would look like. I do that for the graders, but don't do it. And really don't do the rationalization of it, because then you'll piss off the graders because the key doesn't have the rationalization into it. All right. So how do we feel about that one? A little bit more involved. Okay, do you have to write the second row? That's a good question. Okay. So let's see what you have to do bare minimum. So if I was doing the bare minimum for the first one, this is what I'd write. And the important thing is that you have to do it, you only do one layer of derivatives at a time. Okay, so if we were looking at the bare minimum for this problem, okay, it would be as follows, okay? So I would do d over dx of the cube root of ln of x equals, okay? I'm going to do the 1/3. This is the absolute bare minimum. Do not skip this step. Ln of x, you're about to apply the power rule. The only way you know that the power rule is about to happen is that 1/3 power. Now, again, bare minimum. I'm going to take the derivative of the outside with respect to the inside. So I'm doing a u substitution, but I'm not writing it down. Okay? So this is the chain. I'm going to take the derivative of that 1/3. So I'm going to do 1/3 the inside to the negative 2 over 3. Again, bare minimum, I would always do the 1/3 minus 1. But again, I'm doing the bare minimum. Times the derivative of ln of x. That equals, and now I will evaluate this derivative. Okay, this is the bare minimum. Okay, one layer at a time. In fact, that's so important, I'm going to put that in red. One layer at a time. Is everyone on board with that? One layer at a time. No, this is a rule, okay? If you don't write this second row, you will get marked off. That's not just doing it, that's points, right? I think this is too short, but if you do both derivatives at the same time, if you just wrote the second line without, or this third line without writing the second line, it will be marked wrong. All right, that is communication. You have not said what you did with it. Okay? That is bad. And I'm not the only one who'll say that's bad. I mean, everyone's like, oh, but Scott, he's always big on the communication. Nobody else cares. This is one they're going to care about. You don't have to write the chain, but you have to demonstrate that what you did was the chain rule. And you really need to do that 1/3 power. Because if you just start jumping in here, they're going to be like, what did you do? Okay. So one layer at a time. You must have that middle row. Does that answer your question? One layer at a time. Okay. All right. So how do we feel about 2b there, 1 to 5? Let's see. Stop. Start. Okay. All right. So in part C, the journey of x is a little bit different, okay? We've got two x's. We've got x's coming in here, and we've got an x coming in here. So when I write the journey of C, I'm going to do an x. And then notice I have this exp here. And then we just kind of come in here with x because this thing. So the last thing that happens to the x's, the bottom thing is a quotient. So now I'm going to apply the quotient rule. Well, the quotient rule says the derivative with respect to x of x times the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. So I write it out using the quotient rule. I'll actually write quotient on the top. Now, I've got exp of x, so I get 1 times exp of x minus x times exp of x all over exp of x squared. Stop there. Okay, that's your answer. But I want to make a point, so what I'm going to do is factor and cancel here, okay? This is because I want to make a point with regards to the next question. But if you did simplify it, that would be the simplification. Well, it depends what you did. So you could have done a product and a chain, and you would have gotten the same answer. Speaking of which, if we do a product and a chain, let's see what it would be if I did a product and a chain. So let's do a 1 to 5 on this one. Let's see there. Start. So the question was, did you have to do a quotient rule? No, you could have done a product and a chain. As a matter of fact, I managed to pass calculus the second time, not the first time. The second time by never learning the quotient rule. Because I'm dyslexic and I always flip the top. I managed to do it with just the product and the chain. I managed to get through calculus. It took longer on my test than I should have, but I did. And you can actually prove the quotient rule using the product and the chain, and that's on your, that's it, both in the notes from the type notes and on the notes page, and it's on the problem set, how to do that. But that's how you do it with the quotient rule. Now, let's look at the exact same problem with a product and a chain. Right? This and this are the exact same problem. You could convert this to the quotient and do it the other way. And I should say that you can do this with product and chain. Right? CD. Right? That's legal. Okay? So here I did it with that's kind of the point of the problem. Right? The whole point of putting both C and D on the same quiz is to show you that you can do either one. That they're the same thing. Okay. So 1 to 5, how do we feel? That's 2. C and D are the same thing. So how do we feel 1 to 5 about the fact that 2C and 2D are asking the exact same question? right? They're just different notation for the exact same thing. All right, one of them appears as a product, the other one appears as a quotient. I used exp of x here, I used e to the x here, but they're the exact same problem. Okay, well, here's the journey of t if I write it this way, right? I've got t comes in twice, and on the second t here, I've got a negative t, and then I've got an e to the negative t, and then I've got a t times e to the negative t. So t has a bit of a journey here. I've got a chain rule here because this step has got multiple things in it, and I've got a product rule last. So I'm going to start with the product rule, and I set it up here, and I get this. Derivative of the first times the second plus the first times the derivative of the second. And I've got this u hanging out here. All right, because negative t, I can't just do that directly. I need a u there. So what am I going to do? I'm going to set up a chain rule. So I've got the derivative of this is 1, e to the negative t plus t d over du, e to the u, times d over dt of u. And that's going to give me e to the negative t plus t times e to the u times d over dt of negative t. And that's going to wind up being e to the negative t plus t times e to the negative t times a negative 1. Now, you need to stop here. Don't do any more unless you have to. Unless it asks you to. And it should say stop here, not start. And don't go to the stuff in green. But I did the stuff in green to show a point. That if I factor out the e to the negative t and then put it here, I get the same answer here as I did here. Right? They look a little different if you don't simplify. But they're the exact same answer. I think this one's cleaner. But they are the exact same answer. That's why I did the stuff in green. How come on some problems I use exp of x and on others I use e to the x? Well, let's look at part E, and part E will tell you why. So I'm going to hold off on that question. It's a good question, and we're just going to ask how is 2D 1 to 5, and then I will answer that question. So 1 to 5 here on 2D. It's a chain with a product. Okay? Or you could have converted it and then said, see, work in part C. Okay, so why do I use this notation, the EXP? All right? Why the EXP notation? Would you like to do the derivative with respect to x of e to the 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 x, please? Wait, what does that mean? How about this one? D over dx of e to the sine of e to the cosine of x squared plus 5. All right. And it's kind of annoying. It's easy to lose these exponents, especially when they're just written out. It's much easier. This right here is much easier when it's written d over dx exp of sine of exp of cosine of x squared plus 5. 1, 2, 3, 4. 1, 2, 3, 4. All right. This one is easier to read. It's easier to understand that you're doing the exponential of the sine of the exponential of the cosine of x squared plus 5. Okay. And so we have this notation, right? Y exp notation. Exp of x equals e to the x. So we have this special notation for it because these things are not out of line, right? So if you open up a bio textbook or a pharmacokinetics textbook, by the way, this function right here that we did in C and D is very it's everywhere in statistics and in pharmacology, pharmacokinetics, because it's the way that it's in statistics a lot because it's in a bunch of the distributions, and it's in medicine everywhere because this is the expression with a bunch of constants in there. This expression tells you how drugs. This is the basic drug loading curve for the body. So it talks about how the depending on the constants, exactly how the body absorbs medication, and then the liver metabolizes medication. So if you pull it up on Desmos, you can actually see what's going on here. So if I do x over exp of x, and by the way, Desmos even does this notation. So it is a good question. Why do we use this notation? Probably a longer answer than you wanted for it. But if I put this in here, right, this is x over e to the x, and I restrict my domain. I get rid of that, and I only talk about it what happens after 0. You see how this kind of bumps up, and it's got this kind of maximum? But then look what happens to the curve. It kind of comes up, and then it goes down, but then it flattens out. So it goes off to infinity. Its limit is 0. And this is sort of how the body metabolizes things. So it's a very important curve for those of you that are thinking medical school. There we go. Shift, isn't it? Oops. I want to shrink that, and I want to expand that. There we go. So it's if you're thinking medical school, this is going to be a very important curve for you for the rest of you during medical school, because that's kind of how the body just does things. Are there any other questions about that? Of course, with the body, there are a bunch of constants in front of this, right? There's like a K up here, a C or whatever here, and there's usually a shift term as well. But that's basically how it works. Okay. All right, so where was I? And the book, I don't know why the book doesn't have exp of x, and on your test it will be e to the x. But you can convert it if you want to, if it feels better to you. Just know that they're equivalent notations. Does that answer your question fully? Probably more fully than you wanted it done. Okay. All right. So here I've got, for part E is a double chain. So I've got e to the e to the e to the x. So the journey of x looks like this, right? I'm going to get e to the x, and then I'm going to do e to the e to the x. This journey of x does not look good, does it? For some reason, I want to erase. There we go. Thank you. All right, so I've got this thing here. My journey of x here is x goes to e to the x, or exp of x, and then I'm going to go to exp of x, which is conveniently exp of v, and that is going to go to exp of x, which is equal, I'm going to call this u, which is exp of u. Now, it's not important, so if you like to write this like this, you're going to wind up with your u being this, right, because you go in order. And then you're going to wind up with your v being this, and that's fine. It doesn't matter which one is u and v as long as you're consistent. So that's the journey of x. And the way I'm going to work, again, is this way. I'm going to work going up. I start at the end and I go inside. I start at the outside and I go inside. So here's what's going to happen. I'm going to call this whole thing u, and I'm going to go the derivative with respect to u of exp of u times the derivative of u with respect to x. And when I do that, I have an exp of u, and then I get d over dx of exp of x. And I'm going to call this inner one v. So now I'm going to chain it again, and I wind up with exp of u times the derivative with respect to v of exp of v times the derivative of v. And that gives me exp of u, exp of v times the derivative of exp of x. Now, I made these u's and v's. This is obviously going to be the last step. So I'm not going to write exp of u, although I could. There's a step here in the middle that I've cut. There's a step here in the middle that I've cut. Yeah, go over there. So this right here equals exp of u times exp of v times exp of x. And then I sub in all my old stuff again, right? Once I'm done taking the derivative, and I get exp of exp of exp of x times exp of x times exp of x. And if you did it using the other notation, you would have wound up with e to the x times e to the x. I'm missing an e to the x, right? Sorry, e to the x times e to the x times e to the x. Which I just think is horrible. But, you could have done it that way. So 1 to 5, how do we feel about this one? Besides the fact that I didn't leave enough room. All right, this one's got 2 chains. That's hard. Well, as I said, you could. So that's what... Oh, no, you can't add the... Well, yeah, you could. So if you wanted to simplify further, you actually could do this. You could do e to the... Oh, this is unpleasant. You could have done e to the x plus e to the x plus x. So yes, you could have done that. And then I suppose you could have done, okay, well, these exponents can be added. So you could have done e to the, I'm going to mess this up. It would have been e to the, what is this going to wind up being? As I said, I'm going to mess this up. E to the x plus x plus x. Yeah. So you could have done it like that. But I probably would have marked you wrong for doing that because I can't read it. Okay. So if you did that, hooray for you. But if you wrote it like that, I won't be able to read it. I'll have no idea what you're talking about. This would be exp of exp of exp of x plus x plus x. And I would hate you. Why? Okay. All right, now here's another difficult one. Again, simple but hard. This one's actually complicated too. This one is complicated and hard, but not. There's a simple but hard concept and then a complicated thing going on. So let's see here. I want to do that. I want to stop this poll. There we go. So what's going on here? Well, I know that u moves with x. So u down here, x, there's an x that becomes a u, right? The journey of x includes becoming u, but you don't know what that is. And then you also have x becoming sine x. And then you have u becoming u squared, and then you have a product. Well, let's deal with the product first. So when I deal with the product, again, I work outside in. I've got this piece here, derivative of the first times the second, plus the first times the derivative of the second. Now, this is just cosine of x. That's a u squared. That's happy. This is all now baggage. But look at here. I need to apply the chain rule because this is an x. And that's a u. So they aren't the same. So I apply the chain rule to make that u. And I wind up with a dx, d over dx of u. With a derivative of u just hanging out. So now I take the derivative of this bit, and I wind up with cosine of x, u squared, plus sine of x, times 2u, times du over dx. And I can't do anything with the du over dx, because I don't know it. Now, that's not always the case. I might not know what this thing is as a function. I might not know what these things are. But I might have, experimental data about the neighborhood I'm interested in on du over dx. So this is not an uncommon trick. This is called the differential equation, which is a very scary term for saying I don't know what one of the derivatives is. All right. So how do we feel about that? 1 to 5. That's got a bit of a hard concept. Simple but hard concept, and then this is complicated because there's a product going on in there. So 1 to 5, how do we feel about this one? Leaving something in that form, just a little, why am I doing that? Yeah, so you know that. So this could say u is a function of x or u moves with x. They're all the same thing. And I give you a little hint that there should be an unevaluated du over dx in it. But it's not a constant. One of the things I had about WebAssign is whenever they throw in an a, they don't tell you that the a is constant. They're just like, hey, it's an a. Of course it's constant. You know? And this is not an uncommon trick. So let's look at Boyle's law. Boyle's law, if you don't recall, Boyle's law says what happens to pressure and volume of an ideal gas when the temperature is held constant. Okay, so the idea is that a scuba diver at 99 feet holds his breath and swims to the surface, and because the pressure is decreasing as he goes up, as depth decreases, so does pressure. Or as you go down, pressure increases. But as you come up, the pressure decreases, so the volume expands. So a scuba diver that was at 99 feet swims Hail Marys for the surface, holding his breath. His lungs are going to explode because he's got 4 times the volume on the surface in his lungs that he does on the bottom, which is why the first rule of scuba diving is never, ever hold your breath. Because you don't want your lungs to explode. That gives you an embolism that's unpleasant, and you die. So, and you've got no nerves to tell you it's happening because, nature did not intend for you to strap a scuba tank to your back. But to get back here, c is some constant. And so I actually can tell I might have experimental data for this, and my whole quest may be to solve for what v is, or something like that. So I take the derivative of both sides, but I leave this dv over dp unevaluated. And the same thing happens with Guy-Luszak's law and all these others. So scientifically speaking, these unevaluated dv's over dp's are really important. And we're going to get into this when we do related rates. So that's a hard question, but it's an important one. Okay. I guess most of us are 3s on that one. Are there any more questions? Okay. So for the first part of this problem set, let me go over it, because people have been, we've been talking about it a bit. And if you saw on this is problem set 5. This is problem set 6. Okay. So if you saw on if you saw the other videos, I actually went over some of these, and I went over it progressively more and more as it went by. So let's grab your problem set and let's just talk about the first part of it so it doesn't take that long. For this, what I want to do is I want to solve, and this is kind of poorly written. This should be a whole nother page on here, and it's not. And I wrote a note to myself to rewrite it last year. And then when I rewrote it, I cut stuff, but I didn't add any space. But what I want to do when I compute the equation for this tangent line, I want to compute the tangent, the line tangent to the square root of 1/2 square root of 1/2. So what I'm going to do is I'm going to do this. I'm going to use the chain rule to get that slope. So I'm going to take the derivative here, and it's going to be some work. The 2's cancel, and I wind up with this answer right here. Okay. Then I sub in the square root of 1/2, and everything cancels, and I wind up with -1. So my tangent line is y minus the square root of 1/2 minus 1 times x minus all of that jazz. And that's the jazz that's important. If you simplify it, I did the simplification for the key, but you don't need to do the simplification, but I did it here. It winds up being -x plus square root of 2. But I didn't do, you don't need to do that. I just did it because the grader is going to want it. Because some of you will. Okay. And then what I'm going to do is I'm going to implicitly differentiate it. I'm going to do the same thing that I just did for Boyle's law for part F. And what I wind up with, and there's a hint here, a recall, there's like a recall here. That you're supposed to just remember. Okay. And I am going to post this stuff right now in groups. Are there any questions about that? Okay, so go ahead and jump into groups. I'm going to stop the stream, and I will post in general chat here. I'm going to post that. So let's see. Stop